All right, welcome to the second video of week 2, where I'm going to talk to you now about scientific notation. I love scientific notation because it's basically a shorthand. It's a terrific way to represent really large or really small numbers. And instead of writing a bunch of zeros, you get to use this. I really like it a lot for that purpose. You'll find a lot of our examples do not have a gazillion zeros in them just because I don't want it to be a vision test, but hopefully you'll appreciate the fact that it really does have a lot of power to it. And you may be thinking, well, why do we even need to bother? Because calculators will do it all. Calculators do not always do it all. They have limits. If you've ever used a calculator and you get that E, like an error, all right, possibly it means you dealt with a number that's too large for the calculator to handle. Okay, so that's just one. But even if your calculator could do it all, you're still dealing with a bunch of zeros for really, really large, really, really small numbers. And scientific notation is going to help you deal with numbers really large or really small. Okay, so we'll get used to it. The thing to remember is that everything has to be in the form of a number times 10 to a power. However, that number needs to be something where the decimal is after the first non-zero digit, so something like 5.3, 8.2467, whatever, as long as the decimal is after the first non-zero digit. Also, a big thing to remember, see this little multiplication symbol here? That is typically not what we would use in algebra. And so those of you that have used X before for multiplication for your work, I've probably said, hey, try to use an asterisk or something like that. Because X in algebra is a variable that we use a lot. Okay, so I'm going to kind of contradict myself here in a way, but not really. That X that you see is really a multiplication symbol, and it's kind of raised up. It's centered. And so my math lab will not recognize an asterisk in this case, nor will it recognize an X. So if you write something in scientific notation and use the X, you're going to get it wrong. Now, I don't want that to happen to you, so what you'll see to the left of the problem in your My Math Lab work, you will see the little raised multiplication X, okay? And so that's what you need to use in My Math Lab, so make sure you start selecting that little tool to the left of the problem in My Math Lab, and you're going to be fine. All right, so let's get back to scientific notation and what it can do for us. All right, so let's say we had a number like 3.842 times 10 to the 6th, and we want to write that as a decimal. Now, you may say it already is a decimal, but it's not. That is scientific notation. I want to make it just a decimal. What you'll do is notice that you have a 10 to the positive 6. That means I'm going to take the decimal and move it right 6 places. Okay, and when I do, here I am moving my decimal. Oh, only got 3 places. That's okay. I'm just going to add 3 more. And you see it here a lot nicer. Okay, I moved it right 3 more places. So here we are, 6 places. Put my decimal. That's it. Now, if you don't have, and I'm going to erase my notes so you can see it a little easier, if you don't have a decimal point, it is understood to be here at the far right. Okay? Now, in example B, I'm going to go the other way because it's raised to a negative exponent. So I'm going to move this decimal to the left 7 places, and you can see it's already getting bad enough with all those zeros. Got to count really carefully, and when you reach negative 7 places, here's your decimal point, and that's it. Now let's do the reverse. Take a look at example A. I want to write that in scientific notation. So I know I have to put my decimal after the first non-zero digit, which puts it right here. All right. Now, how many places do I have to move it to get it where it originally was? Well, the original problem had no decimal point, so I know that really means it's to the far right. So I have to move it 1, 2, 3, 4 places to get it to the original spot. And that's why this answer is 9.4 times 10 to the 4. Let's look at the next one. And basically, if you have a big number, it'll be 10 to a positive, and if you have a little number, it'll be 10 to the negative. So on example B, okay, where do I have to move it to where it started? Well, first I have to place it after the first non-zero digit, which is right here. And to get where I started, I have to go left 2, and that's why the answer is 4.23 times 10 to the negative 2. That's really all there is to it. You'll find we can do some calculations with it. We can use our old friend, the commutative property, and also the associative property, and you might see something like that, and you might say, well, you know, I can just use a calculator and multiply it just the way it is, and you can, but multiplying 1.7 times 2.2 is so easy. That's just 3.74. I still used a calculator for that, I'll be honest with you. But 10 to the 8th times 10 to the negative 5, those are our exponent rules back, right? So I've got 10 to the 8 plus negative 5, or 10 to the 3, and I'm done. Pretty easy problem. So you can see other calculations we can do with it. And that's about all I have for scientific notation, but you'll see more examples in doc sharing. The next video we'll start looking at radicals.